Hello everyone, welcome back to my channel Bit Beyond the Books. Today we will be completing logic. I am really sorry I won't be able to complete the fallacies chapter today. I am not really confident with regards to it because I haven't solved many statements, and when I am not confident I don't think it will be good to explain the concepts to you. But I'll ensure that I complete the fallacies within this week and come up with part 2 of logic for fallacies especially. Once I do that, all my notes will be uploaded in a single drive. So let us quickly begin with nature of proposition. We have already studied the types of sentence numerous times. A declarative statement or sentence is known as a proposition, or rather is a proposition, and it is further divided into compound proposition and simple proposition. In simple proposition, there are 4 subtypes: subjectless, class membership, relational, and subject predicate. Subjectless. As the name suggests, this proposition does not have a subject. For example, bomb. If someone yells bomb, so you'll directly run, right? You won't really wait to ask what, where, how, or any other question. You know bomb is a threat, so you'll directly run. Class membership proposition. This type of proposition tells you that the person, animal, or thing belongs to which class or a group. For example, your name. Let us say you belong in the logic class. So this statement is telling that you belong in which class? Logic class. That is why class membership proposition. Relational proposition. This proposition gives you direct comparison between two or more people, objects, so on and so forth. For example, XYZ is smarter than ABC. So in terms of smartness, it is telling you who is smarter. Further coming to subject predicate, I believe it is pretty much self-explanatory. This type of proposition has a subject and it also has a predicate. Let us begin with decision procedure now. A truth table is also known as a decision procedure. Why? Because it is reliable, it is mechanical, and it follows certain rules. So how do you construct a truth table and what is it exactly? In a truth table, on left hand side you have your matrix and on right hand side you have truth functions. So in the matrix, you write the number of variables, or rather the variables at the top. For example, we have only 2 variables here. So we have written P and Q. How do you calculate the number of rows and number of columns? The formula is pretty simple, 2 raised to n. The n here stands for the number of variables. So we have just 2 variables, therefore 2 square is equal to 4. We'll have 4 rows and 4 columns. On the basis of this, we construct our matrix. Under the most right hand side variable, we will be writing a combination of true, false. As we move towards our left hand side, number of trues and number of false will increase. For example, here under P, there are 2 trues and then 2 false. So on and so forth, it will keep on increasing as per number of variables. We will decide the number of rows on the basis of this formula. So truth function. How do you calculate this? Now this varies as per statement. If it is conjunctive statement, disjunctive statement, biconditional proposition, so on and so forth. Hence, it is really important to memorize the symbols with respect to statements. Otherwise, we won't be able to construct the truth functions part correctly. So here, I am beginning with a conjunctive statement, P dot Q. First and foremost, what I'll do is I'll simply copy the variables true and false mentioned under P and Q respectively. So truth value. For every type of statement, there is a truth value. In conjunctive statement, its value will be true only when both conjuncts are true. And even if one of them is false, it will become false. So both are true. Okay, true. One is false, false. One is false, again false. Here to both are false. So again false. Similarly, there is a different truth value for each one. Let us come to disjunctive. As per this statement, disjunctive statement is false only when both are false. In remaining cases, it is true. So it is exactly opposite of conjunctive statement. Hence, the truth value will come as true, 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 false. Conditional or implicative proposition. It is false when antecedent is true but consequent is false. In remaining cases, it is true. So, antecedent is true. Consequent is also true. So, it will become true. Antecedent is true but consequent is false. Therefore, the value will come as false. Your antecedent is false but consequent is true. So, this case is not applying, right? Hence, in remaining cases, true. By conditional proposition. Its truth value is true when both conjuncts are true. Otherwise, it's true or either both conjuncts are false. So it is also equivalent proposition, right? So if P is true and Q is also true, the truth value will come as true. But if they vary, for example, P is true but Q is false, then the truth value will come as false. So on and so forth. Negative proposition. Truth value of tilde will be false if the value under variable is true, and the exact opposite will happen when it is false. How do you get the type, as in how do you state the type? There are three types: contingency, tautology and contradiction. The variables under main connective can come only in three combinations: either a combination of true and false, either all will be true, or either all will be false. So if the combination is a mix of true and false, it will be contingency. If it is only true, it will become tautology. If it is all false, then it will become contradiction. Last chapter for the day, deductive proof. This chapter forms heart and soul of our 12th grade, as far as ma'am has told us and one of our seniors. So yeah, all these rules are a little difficult to memorize, but it's not impossible. You need to practice as many sums as you can. We were given 101 sums to practice, so that is quite enough. And I have solved majority of them twice. Yes, twice, thrice. So it's a good practice. And there's nothing really which can be explained in these rules. You need to memorize them. You don't really have an option. They are 19 in all. First set are the rules of inference. They are 9 rules. Second is the rules of replacement. Rules of replacement can be applied to a part of the statement, but rules of inference can be applied only to the entire statement. So yeah, that's all for today. Thank you so much.